Welcome, everyone, to Stay Curious. I'm your host, Mark Marquette. Always my pleasure to bring you a special program with a guest, and none is more special to our museum than the gentleman beside me, Mr. Terry White. Hello, Terry.
Hi, how you doing?
Great to see you.
Good to be here.
Good. Good humidity day for your mustache, it looks like today.
Yeah.
Terry, of course, is a manager of the shuttle program, involved in all 30 years of our, and before and after even, of our illustrious 135 missions. And today we're going to talk about something I asked him to talk about, the shuttle tires. So you regulars out there are going to enjoy a wonderful program. Those newbies out there are going to see how we do programs here. Very insightful about some of the minutia of the shuttle program that I'm so fascinated that after 14 years from the last touchdown,
Yeah.
just 10 miles away from where we're seated on the shuttle runway, people are still fascinated with the shuttle era, Terry.
They are. Yeah. It was an amazing vehicle, an amazing program.
And I don't think it'll ever be duplicated. It for a long time, John Blaha, the great astronaut, personally said to me he don't think it'll take 100 years for some nation to or civilization to create another orbiter like this.
I think so because no one's pressing in that direction anymore. So.
No, they want a single capsule and
Yeah.
ballistic type of capsule thing, which is tried and true, of course. So we're going to enjoy learning about the shuttle tires here in just a minute. Let me set up a couple things that I know you know former Kennedy Space Center Director Jay Honeycutt very well. And American Space Museum is kicking off a NASA Legends Dinner on Wednesday, September 10th at the Italian American Club in Melbourne. It's $50 a person. If you're local, we get half of that to support our American Space Museum as a mini fundraiser. And we hope that people support Mr. Honeycutt. You and I, you've known him a long time. I've gotten to know him the last 3 or 4 years. Really an outstanding manager and person that seemed to have come around at the right time in the shuttle era.
Yes, and to listen to his history, he was more than just the director of Kennedy Space Center. You go back through his history, he had an amazing career in the manned space program.
He actually worked in Houston on the as the manager of the simulations for the Apollo missions that they threw the monkey wrench into the your Gene Kranz's and Tunney's and other flight directors there to see how they'd react to things in there. So
yeah, and he apparently had a good time challenging them on all this.
It seemed that that's his demeanor, is having a good time, but serious hard worker. Then Jay Honeycutt was very importantly one of the managers of the shuttle era. He picked up the pieces after the Challenger disaster. He was actually one of the people who helped write the Rogers report on the Challenger Commission. He gave me a copy of it that he signed. He said it was my job to proof every page of this thing. Of course, the report that reported on the Challenger disaster in there. So I hope you all locals can come out and support Jay. A delicious Italian dinner, and you're going to hear stories from somebody who lived it and is not afraid to talk about it. And we had a wonderful tribute to George Abbey, the great leader of Houston and Jay's boss and great friend who died last week. We had Mike McCulley here and Jay talking about the great George Abbey. And that was a very popular show, thanks to all you watching that up there. So also one other publicity to take care of here is we have an auction on Saturday. This helps our American Space Museum to the tune of over $5,000 or more each auction. It goes into our cash flow, and we are grateful to Bid Again Auctions owner Chuck Jeffrey for what he's done the last 10 years on these auctions to provide a viable funding source for the American Space Museum, but also, more importantly, get cool space memorabilia in the hands of people who really appreciate it out there.
Yep.
So you can buy a shuttle tile. You can't buy a tire in this one. Once in a while, a tire does come up there. So, but we've got Just say hi to RG Jubilee, Mark Thel, Cliff. Cliff will be on there. Where's Cliff in Australia? Mitch Rothman of Man Space Facebook, Gary Gerald, Tommy UCX watching, Dean Babcock, Steve Jokums is going to be loving this program for sure, and Carlton Bailey in Thunderstorms in Canaveral Groves. And we are going to have a lot of Carlton Bailey photographs today of the landing gear, front and back. Thank you, Carlton, for digging into your archives to help us put today's show together. So I see Elena Adkahara, she's in South Africa, and Nick Deacon from the UK. Thank you, Nick, for becoming a regular. And Tom Celentano is joining our social hour here or so with Terry White. And Terry, what's this a beautiful shot here that co-producer Marty Winkle has chosen for our backdrop. While we have it up there, we'll tell you later, is it going in or out? But when you have a trained eye to look at these things like Terry, I'm going to ask him, the yellow lines on the concrete there obviously might have something to do with the wheel tracks.
That is. That's the path that the nose in the center and the two mains on the left and right follow in to be spotted. It has to be spotted in exactly the right position so that it fits with all the infrastructure in the Orbital Processing Facility once we get it up to its maintenance height and lower all the platforms down around it.
And when we get into the OPF, we'll see a couple pictures inside, one or two. But I've always been told that you couldn't really tell the shuttle was you've had people come in to the Orbital Processing Facility, look around and go, where's the shuttle at?
That's because we had it at what we call maintenance height. So we brought it in. We used, in the early days, we had jacks that we actually hand jacked the orbiter up and then put it on special supports and that. Then eventually we did modifications and installed hydraulic lifts into the floor of the OPF so we could raise it up using those lifts and that. But you raise it up to what we call the maintenance height, and that's where all the platforms and interfaces and support equipment could attach to it, and that you could open and close the payload bay doors and that. But when you walk in there, you actually walked underneath the orbiter, and it was another 10 feet or about 8 feet above your head. But people would come in, guess, and look around and says, I thought you had a space shuttle in here. I said, we do. It's right above your head. And they'd look up and they said, we just thought you had an ugly ceiling.
Yeah. I mean, it does kind of look like that. So.
Yeah.
So there's a little bit there. Which one's you there, of those people sitting there? You could be standing out there, couldn't you, Terry?
I could be, but I was probably off to the side. So.
And what I want to point is between our shoulders here is this yellow flatbed there that was used. I'm not sure which orbiter you started using it, but the flatbed has a story. Where'd that come from?
That's the orbiter transport system. That was built to move the orbiter out at Vandenberg Air Force Base.
On the highways?
Yes, on the roadway. It was 19 miles from their processing facility to their launch pad to where they stacked it. Now, in Florida, it's only a few hundred yards from the orbiter processing facility into the VAB. So in the early days, we rolled out on our flight tires and that. But when they decided not to launch from Vandenberg, that orbiter transporter was a surplus piece of equipment. Well, we were rolling out one night, and in spite of all of the walk downs and checking for FOD, foreign object debris, on the towway on our way over, we rolled over a bolt, and it punctured the tire. It did not get all the way in to release the nitrogen, but still, that made the tire no longer flight worthy. So we had to change the tires when we got into the VAB. Luckily, in those days, we were routinely building up tire systems, so we already had another tire that was all pressurized and all decay checked and that. Because what people don't understand is once we close the landing gear for flight and we mate to the external tank, you have no access to the landing gear. You can't top off the tires. We had a monitoring system that you could monitor the pressure, but otherwise you couldn't get to it because the landing gear doors is right up against the external tank. Yeah. So the length of time in the VAB and out at the pad and mission in space and that, those tires had to maintain the pressure for all that time, which wound up being several months in some flows.
So yeah, right, delays and stuff like that. So you that's what this yellow is there.
Yes, yes.
It came from Vandenberg, and then
It's got the same attach points we used to attach to the external tank and that. So that's what's sitting on the orbiter transport system. And the transporter has 72 wheels.
oh wow,
You have to support all that. So
but now you know, and fix a flat tire in the VAB. That would be something to be seen in there. So, well, we've got to have the shuttle go to space before we can leave the landing gear. This is either Mark Usiak or Carlton Bailey's shot off of the vehicle assembly building. I think Marty Winkle's up on his yacht up there, watching from the Port St. or from the Indian River there. But no, I'm teasing Marty being here. Our producer, co-producer Marty's on our Streamlabs board here, and he certainly saw his share of shuttle launches and landings. But there's the last moment before the wheels come down, and tell us is it automatic? How do the wheels come down? What's the story
a
about
landing gear deployment is not automatic. It is performed by the crew. It takes about 10 seconds for the gear to come down, but it does not come down till you are extremely close to landing. You want to eliminate the drag of the landing gear and that on the vehicle, plus you have to get the vehicle to a certain slow speed to do it. But then the pilot, it's his responsibility on the command to push the thing that deploys the landing gear. The landing gear is not just a simple come down hydraulically like an aircraft and that. It has a triple redundant system. So we'll get into that a little bit more as we get into the show.
Absolutely. Marty's got a quick question concerning what we were talking about there.
Yeah, I'm trying to find a question. I forget who asked it. Wait a minute.
Gary Gerald.
Okay. Gary, what happened to the transporter after the program ended?
I think SpaceX was using it to move some of their vehicles around.
Is that right?
Yeah,
and,
but Mark, just yesterday at the Space Center, they were moving the transporter down Saturn Road, US State Road 3.
Yes.
Towards the VAB.
Okay.
Yeah. So it's still out there.
Yeah, it's still out there. Yeah, I just don't know what phases they're using it for.
Yeah.
So.
Well, we've got a lot of questions coming in already, and I guarantee you Gary's going to ask, or Terry's going to answer some of your questions here about tire pressures being asked. Did the wheels spin up before contact?
No, they did not. They were static.
Steve Jokums, he's correct, thinking of SpaceX, and maybe other people are using that. And again, what is the Rosalie Jubilee there is asking, how heavy is the shuttle that those tires got to withstand?
I think that is 172,000 pounds.
Okay. 100 tons. I mean, 100 tons basically.
Yep.
200,000 pounds would be 100 tons.
Yeah.
So,
yep.
Heavy on those tires.
Landing weight could be as much as 214,000 pounds.
Okay.
So yeah.
Bringing back a payload or something.
Yeah. Now, if we never did it, but if there was a problem at launch and they opted to return to landing site, they would be coming in at over 256,000 pounds. But that never happened in the life of the program.
Boy, are they glad of that it never was attempted there, the return to launch site abort scenario. So they're coming in, and whose job is it to spring out the landing gear?
It is the
awesome photograph.
Pilot's responsibility. The commander is flying the vehicle, and the pilot has the responsibility of deploying the landing gear.
Okay. And there was some talk early in the program that they could have landed autonomously. The shuttle could be launched and landed with unoccupied, and astronauts didn't want that, did they?
No, and I don't think I knew of anybody in the program that wanted it. But basically, they didn't want to take the chance that somehow during orbit that the landing gear deployed, because if it did, they could not get the landing gear closed, especially the nose landing gear, and you cannot re-enter the atmosphere.
Why
with
is
your
that?
landing.
Everybody, airplanes can retract their landing gear up and down.
Because the hydraulic system on the orbiter was designed to quickly deploy the landing gear, but it takes a while to raise the landing gear. But because of the thermal barriers that protect around the nose landing gear doors, we'll get into that in a minute when we explain the Broom Crew, but the hydraulics is not strong enough to raise the nose landing gear and close the doors.
Interesting there. And that was a concern of John Young. I've heard a story of that great astronaut writing STS-1 with Bob Crippen. He asked some engineers, how can you assure me that the doors just aren't going to accidentally open in space from some glitch? And I think the answer was we can't, but we'll figure that out. And they put an extra switch relay or something in there.
So it wasn't set up that someone physically had to deploy that switch. Now later on, we went to a modification where I think it was post Columbia, but they did come up with a program that the astronauts could load while they were in space. That then would, if they abandoned the orbiter and went to another orbiter or to space station, and they attempted to bring the orbiter in, that it could deploy the landing gear without somebody pressing the switch.
I didn't bring a picture of it, but we have two tires, a main landing gear tire and a nose gear tire that was used. The main gears was rejected because of some wood in it, actually, is what we were told in the paperwork in there. But we're going to show you a close-up of one of the tires we do have here in a minute or two, and let Marty get his zoom fingers going there. But one hell of a photograph there with a telephoto lens. That's the White Room crew and their vehicle there, other people there. Well, maybe that's not all the White Room crew, just because they're dressed in white. But what was that like?
That was our flame retardant coveralls.
Okay.
All right. That was part of the thing that you had to wear out there. So
what did it sound like? This is a glider. There's no engines running on it.
Nope. Other than the auxiliary power units, but you have to be closer to them to hear the noise out of them. But no, it's there. And the most impressive was a night landing, because there's no lights on the orbiter, and they're not shining a bunch of lights at it, because then that would affect the commander's vision and that flying into a bunch of bright lights. So they're coming in the dark, and you're standing right next to the runway waiting for them to come in. You know they're close because you've already heard the two sonic booms, but you're waiting, and there it is coming by you at a little less than 200 miles an hour, a few feet away from you in the dark, and now you can see it.
And what'd you hear? A big
Just
whoosh?
as it goes by. Yeah.
Marty, you've been to a few of those on the runway. How about your impression?
No, I haven't been on the runway during landing, but even where I was still located, I could still hear the switch going by.
And a lot of the noise was the mosquitoes. There's a lot of mosquitoes at the runway.
That's right. Occasional growling alligator. Wonder what's everybody waking me up here for. Well, of course, every one landed that got to attempt a landing very well. Astronauts also kind of bragged about there was actually a spot on the runway where they were supposed to have wheels stop, correct?
Yes.
And some of them bragged about how good they could do that.
But that was squelched, because they used to brag about who got the closest to the spot. And NASA says, no, this is not a competition.
But who who got the closest to the
I
spot?
don't know. I never went out and checked who
you didn't? Well, our rumor is that Eileen Collins, who flew those big C-140s and so forth, landed more
C-141s,
accurately than anybody did.
I don't know.
Who was said out there. Marty Winkle's got a question from one of you brilliant viewers out there. Take it away, Marty.
Yeah, Michael Bruno was asking, I guess tires were only good for one landing cycle, or were they reused?
The main landing gear tires were used once because of the stress they saw on touchdown. Like I said, the tire is not moving, so when it hits the runway, close to 200 miles an hour, it's a big scuff mark on the tires. Now the nose tires also get a scuff mark, very minor compared to the mains, but we inspected them, and we generally got 2 flights out of a set of nose landing gear tires, but only 1 out of the mains.
And burning rubber on the main landing gears.
Yes.
And a question was asked, what were they inflated to?
Okay, the mains were inflated to 341 pounds, and the nose is no, the main's 410 pounds. Initially, it was 300 and some pounds, and then after modification and going to a slightly larger tire, they went to 410 pounds, and the nose were only 300 psi, and they were not inflated with air. They were inflated with nitrogen.
Why?
Well, several different reasons, but the temperature differential, there is no problem with the nitrogen in that, and there's no problem with the difference in pressure in space from what there is down here because of that. But the nitrogen could handle the weight loads and that, and the tires were not radial, they were bias ply tires, and
they went through a manufacturing.
Yeah, and originally Goodrich had the contract for the tires, and then Goodyear got the contract, and eventually Michelin bought out Goodyear, so the last few flights were on Michelin tires.
Couple more questions from our viewers. Marty?
Yeah, Steve Holcomb is asking, did the tire reusage rates change after they grooved the runway?
No, it did not. But we did change. There's really not much tread on the tires because we realized there was never any tread like there is on a big truck tire or an automobile tire. But we don't land in rain, and like Marty said, the runway's grooved to get any moisture off of it and that. But yeah, we saw a lot of stress cracks from what little bit of tread there was on the tire. So basically toward the end of the programs, the tires were almost completely smooth.
Interesting. We've got one that's got a little bit of raised tread on it here, but put slicks on that.
We got a question from Tom Celentano.
Okay.
Was every landing accompanied by chase planes? I remember hearing that engine noise on TV during landing.
Yeah, so there was T-38s and the shuttle trainer aircraft were generally flying that, but T-38s would fly alongside it. They flew alongside during the landing tests at Edwards Air Force Base, and then they flew on all of the missions coming in. The T-38s would fly alongside them.
Seemed like that's quite an honor for an astronaut to be a chase plane
Yeah,
pilot.
and also you're looking for things they can't see out. They can't see the outside of the orbiter.
Right.
And what we can see with cameras, but that one flying along, I mean, the military does that. If there is an aircraft that suspects have battle damage or something like that, other planes will fly alongside it and go all around it and that looking for any.
And I've brings back John McBride, who was Chase Plane 1 on the STS-1 landing. And he was, of course, flew flight and passed away a year ago. God bless your family there, John McBride from West Virginia. But his commentary as he's looking is, I don't see anything flying off of it. Everything looks intact. No tiles are flying off of it. I don't see anything burning. I don't see any smoke. I mean, this is how he was talking, to the ground control people as he's flying beside it.
Yeah, you have to relay what you see because they can't interpret because they don't have your eyes.
Yeah.
So you have to explain everything.
Very interesting. Go ahead, Marty, with another question.
Yeah, Doug Forrest is asking, since the landing gear deployed so close to landing, was there any emergency plan for a landing if the landing gear failed to deploy? Would it have had time to divert to a water landing?
Well, no. You would do a belly landing and create a lot of work on the orbiter's thermal protection system.
And not tell anybody else on board because they'd be flipping out.
But yeah, you're so close to touchdown, you couldn't abort to anything. Yeah. So
200 miles an
remember,
hour.
you have no power. You're just a glider. You're just coming in on the airspeed that you got. But they designed it with basically a triple redundant system. So there was a lot of things that came into play to deploy your landing gear. Okay, in the mains, the first thing it would do is release the gear up lock and the door locks because the doors and the landing gear are connected. So as the doors are opening, the landing gear is coming down. Okay, and that's done hydraulically. It has a pyro backup system, and it has a spring bungee door extension booster, plus you have the airflow. As the gear starts coming down, it's catching the airflow, so the airspeed is pulling it down, and you have that little commonly known thing that we ignore every day, gravity. Yeah, the landing gear are heavy in that, so gravity is helping to pull them down. In the nose, once you release the gear up lock and the door locks, you have the hydraulic system and a pyro system that fires it, and you have a spring-loaded bungee assist system. So then you also have the aero and the gravity to assist it as well. But we actually cock the bungee system when we raise the nose, so it helps slam it down. So even if the hydraulics didn't work, once those locks are released, they're going to slam that gear down.
And we'll see some of the details of this engineering of these wheels here. And another question from you wonderful observers.
We got a question from RG Jubilee. What was the speed of the shuttle as it landed?
Okay, it varied, but I was trying to see, I had my notes here that had what the different speeds were, but it was, in the neighborhood of 200 miles an hour when it's coming to touchdown.
Pretty fast. That is the speed, the top speed of many professional race car circuits, like your Formula One in the Netherlands this weekend. That red Ferrari will be hitting 200 miles an hour in the straightaways, as is the kart, the open wheel here in America. They go 200 miles an hour. NASCAR doesn't hit 200. They hit 200 maybe at Talladega, down some of the backstretch there. But thanks for asking your questions there. As you all that love the shuttle know, the first 48 of them landed without a parachute. We have a landing at all three places where the shuttle landed, shown here. Kennedy Space Center, above Terry's, where the parachute's coming out in Edwards Air Force Base, where Terry's head is, and then the one landing, STS-3, out at White Sands. That was not an emergency, except that everything was run. They had to get down in another day or two.
Yeah, they run into
expendables.
Yep, and both California and Florida had weather issues that they could not bring it into either location, so they opted to land at White Sands. And
so the first shuttle to land with the parachute was STS-49, the maiden flight of Discovery. No, not Discovery. Endeavour. Yeah, maiden flight of Endeavour that replaced the Challenger. So, of course, 48 launches before that, Challenger didn't land. So 47 times it landed without the parachute. Why'd they add the parachute?
Well, initially it was designed to have a drag chute, and then weight-wise they said no. But because of the stress on the brakes and the tires, they opted to go, and that was one of the fixes after Challenger was go install a drag chute. Endeavour was the only orbiter that was built with a drag chute mod. The other orbiters were retrofitted with drag chutes here.
And allowed did you have to replace the brake calipers, so to speak, and everything?
We did, and there were brake mods done over the years to beef them up and that.
All right. Another question, Marty?
I think Babcock is asking, did any shuttle ever exceed 200 miles per hour on landing?
Well, I don't have the figures but our deployment velocity was supposed to be 312 knots, if one of you can convert that to miles per hour, and the landing velocity was supposed to be 225 knots.
I don't have my knot converting chart with me here. I can convert Celsius to Fahrenheit, though. 2/3 times the Celsius and add 50. There you got the Fahrenheit.
So, and luckily in all those landings, we only ever had one blown tire, and that was on 51D. We had one tire blow on the mains.
Oh, really?
Yeah.
That'd be Discovery's maiden flight. And Charlie Walker, I think.
50, it was flight 51D.
Or 41D was
the
main flight.
And that was a
Anyway.
main gear tire failure, and that was the only time we had that.
I'm gonna not pretend I know that much, because I've got the expert here with me that you all are enjoying, Terry White, joining us today on Stay Curious as we talk about the tires of this shuttle, of our wonderful 30-year shuttle era. And let's look a little bit at some of the pictures here as we go along here. It lands. What's this about here?
Okay, post landing we have to get The temperature control system's hooked up, so those big red hoses there are pumping the air conditioning into the one for the
There's a vehicle.
yeah,
to the
one
left
for the
there
forward, one for the mid body, and one for the aft. So we have spacecraft operators are in there that like to be able to breathe and have conditioned air. Plus any payloads, we have to keep them at operating temperatures and that. So all that's hooked up. That's done at the runway. And as soon as it's safe enough to get around the orbiter, and then that stays connected till we get the orbiter. What's doing right now is coming into Orbital Processing Facility number 2. We'll get it up to its maintenance height, and then disconnect that and close and operate under the building's air conditioning system.
And you new viewers to the and to the shuttle in general, the stabilization rudder there. They instead of having a big door, you just cut a hole in it there, so you didn't have to have a
well,
big
this is
high
this
bay.
is the OPF. It was designed for that, so that was initially done. It was a VAB. We had to make the door cut.
Uh-huh. And then this is a 360-degree crazy photo inside the VAB, but it shows
Inside the
wheels.
OPF.
That's why I mean OPF. Yeah,
Yep.
sorry. So the trained eye, untrained eye sees things like yellow jack stands. The wheels there. You're looking at the tile above you.
Yep. So we have to support the orbiter, like I said earlier. Once we get it up to its maintenance height, then we have to support it with jacks. Those are the 2 aft jacks that support at the external tank door opening and that. And then there's 2.
Oh, that's where you would put them. Okay.
Yeah, and then there's 2 other jacks that support at the sides just after the crew module, and they attach into the side of the orbiter, and they support the nose. That way we can raise and lower the landing gear. So we can do all of our checkout for the landing gear in the Orbital Processing Facilities where we're supporting on those jacks.
And there's the picture we chose of this is actually not going in, but going out.
Coming out,
Say.
yep. So, yep, we've got the protective covers on the engine bells. Those are all refurbished engines ready to go for another flight. The orbiter's all ready, and we're leaving the Orbital Processing Facility, and that looks like OPF 3, heading for the VAB.
That's Atlantis, as the tail says there. If it was Columbia, you space aficionados would know that right off, wouldn't they?
Yep. 2 things would be the wing glove, which was the forward portion of the wing. Go further up, further up.
You raise up there with your hand. Your other hand. There you go. Yep.
Yep. At any rate, I'll get it right.
Yeah.
Yeah. Just forward of my finger right there. And that area was painted black on Columbia before the very first flight because they were worried about the temperature differential from space and then coming back to the heat of reentry. So they wanted us to paint the wing black so that it would absorb heat when they rolled toward the sun. Turns out it wasn't necessary, so we did not do that to the other orbiters. But since we'd already painted it black, we kept it black. Plus, it doesn't have the silts pod on the top of the vertical stabilizer. So those are 2 things that identify it as Columbia right off the bat.
And the pod was a sensor with cameras on it and other things like that.
And we quit using it, but we never had time to go take it off and put its original tail back on.
We'll talk about it another day, but I don't know why the thing wasn't covered with cameras like the Starship 10 was that we saw the other day on there. But going out for another trip to space, look at the patina on it there. Wonder what's inside that cargo bay. Well, let's get into the minutia of now we're getting ready to go back to space.
Okay. Now we've rolled over to the vehicle assembly building, and you can see the nose landing gears down. So we rolled out on our tires. This was earlier in the program. And we have attached the sling that's going to lift the orbiter in the air, and that same attach point that you see just after the hatch, that's where that jack in the OPF supported it. But now we have 4 attach points on the vehicle that this huge sling fastens to, and 2 overhead cranes lift the orbiter up off of its landing gear, and then we bring up hydraulics, and we will close the landing gear in the VAB, and then eventually take it up to a higher level, lower the aft end down and disconnect the aft crane, so then it's lifted up to go to the external tank and boosters on a single crane.
Excellent, excellent. We got some good comments here, and I'll get to those, Marty, here that Gary Allgaier, our structural engineer, and you know Gary on there, He says, and he's in Georgia, landing gear was gravity drop for landing. Hydraulics was only used to retract the gear in the OPF.
Huh.
So,
That isn't what the hydraulic system says.
okay.
But I'm not the hydraulics guy, so
But we'll compromise there and just say you both know a lot about what you know about. And Michael Bruno wanted to know, would the engines always have to be refurbished between missions?
yes.
Not only refurbished, but completely taken off the vehicle and not matched up quite. You have, how many? But there
Well,
was, Marty, there was like 25 SSME engines or in storage or something.
Yeah, and they have different. The engine guys told me that they have different ratings, so they matched engines to the weight of the payload, to the vehicle, and that. So they weren't all exactly the same.
Marty commented that he was a launch process engine man.
I can't comment on that because I was responsible for the main engine computers, not the main engine itself. So,
well, I never thought of that, Marty. That some engines would be maybe hotter, meaning more power to them than another engine, for example.
It's just like if the three of us went out and bought 3 identical trucks, then they're all going to operate slightly different, you know. So, you know, that's what the engine guys told me, is they matched that, and that's why, you know, a lot of stuff is matched to a certain thing. You just can't go change right over to something else.
Now, what are the yellow things there?
That is the lifting fixture. So that is what actually attaches to the overhead crane, and that's like a big sling that you attach to it to lift the orbiter.
So our building supervisor here, Dan McCune, he was a crane operator. So he would be 300 feet in the air working on this.
500 feet in the air.
500 feet in the air, yeah. Oh, he's up 500 feet in the air, okay.
Yep.
He scurries up a ladder like he can't, like a squirrel sometimes. He's not afraid of heights at all. Here's another angle. Thank you, Carlton Bailey, for providing us these photos inside the VAB. That must have been quite a thrill for you, CB, to be watching this going on. And he was properly credentialed, as we'll see here in a minute or two there. Just another angle of that. And again, now some of the...
now you can see the aft portion of the sling and the forward portion.
Okay. What I always find interesting is, like any workplace, everybody just kind of wore what they wanted to work. There wasn't a lot of standardization among OPF workers that
it had to be closed-toed shoes, and lifting operations, they had to be steel-toed shoes, long pants. You could not wear any tank tops, anything like that, but basically short sleeve or long sleeve. But then depending if it was hazards involved in the operation, you may have to wear the white coveralls or the blue coveralls.
Yeah, but if you wanted to have a Beatles T-shirt on or
that was acceptable as long as it wasn't a tank top.
Okay. All right. Good. Darn it.
Yeah.
All right. Another view of Carlton's. Again, now you're seeing the whole yellow structure there.
Yep.
And what's involved. And that lifts it up like a yoke. But you got to get that. It looks like the rear landing gears are up, but not the nose gear.
It's hard to tell from that picture. Well, the hydraulics doesn't have the power to raise the landing gear. We thought it did. In all of our initial testing, we didn't have the thermal barriers, the seals around the nose landing gear doors to protect the gap and re-entry. So when we're raising the gear, mains come up first, then the nose comes back down, then the nose comes up, then as it's coming all the way up, the doors close and latch. Well, once we put the thermal barriers in, the hydraulics could not raise the landing gear. It could raise the landing gear, it could not do the final to close the doors. It didn't have enough power. So that's when we came out with the Broom Crew.
Before we show you the Broom Crew, we want to show you in this picture here, Terry did a program a couple months ago on the chin of this shuttle, and this shuttle does not have the RCC. I'll get it right one day. RCC, which stands for
Reinforced carbon.
All right, reinforced carbon. That white those white tiles are where the chin is, right above.
And those
the
aren't
wheels.
white tiles. That's tape and protective covers for the thermal barriers. But just aft of the nose cap itself is rows of tiles. See here, there's no tiles on the structure, just off of the landing gear door, just for the landing gear door, because it has the chin panel to cover that. That was a mod we did because the tiles up there were slumping from the heat of reentry. So we sacrificed weight and put on the chin panel, which was heavier than the tiles, but it stopped that overheating in that. But so this does not have the if I can get up to it at any rate. So it does not have the
You're looking,
yeah.
right here.
yeah.
You point up above your head. It's that little piece right below the cone.
Yeah.
There.
It
And
don't
the
work
door
right.
there.
So, yeah. So yeah, it's the what's on the structure just forward of the nose landing gear door. So yeah.
Well, I felt cool talking to Ann Miklos, thermal protection system lady, that I said, I learned where the chin of the shuttle was.
She laughed.
Yeah, she said, "Well, you learned from Terry White, I'll bet." And I said, "Yeah, sure did."
Yep.
But it's interesting and fun to know things like this, and improvements that were constantly made on the shuttle, which after 135 launches was truly considered still a test vehicle to the end, as you were changing things left and right and improving things on there.
Now to assist that nose landing gear doors in closing, we even installed a material on top of the thermal barriers that was removed once the doors were closed, but it was like a Teflon coated fabric, real thin, that we put up there, and that's what you can see that looks brown and white, just after the nose cap right there, and it's all around the doors and that. So once the doors, we did get them closed all the way with the assistance of the brooms. Then when they brought down hydraulics, we had to remove that film, and interestingly enough, we're doing that while the orbiter is suspended by the crane in the VAB. So just like anything that's suspended at the end of a long rope, it doesn't take much of a touch to get it to move, to swing. So we're up on the stand.
Oh, yeah, right.
The techs are pulling the Armalon out, and the entire orbiter starts swinging. And everybody around on the ground center was getting really excited because this 250,000-pound vehicle is swinging.
But how much was the swing give?
It was enough that they saw it right off the bat. And so everybody says, "Oh no, what are we going to do?" And I says, "First thing we're going to do is stop it." And I put my hands on the orbiter and held it, and it come to a stop.
Hercules.
Yeah. And I said, "Now the next thing we're going to do is we're going to make sure, because I'm going to stand there and monitor them, that they're pulling from the left and the right at the same exact time. Some of them came out easy, some of them came out tougher than that, but you're pulling exactly the same so we don't get it swinging." But everybody was getting ready to make phone calls and stop the operation, and I said, no, we can get this squared away. Just give us a minute. So yeah,
Well, you're closing a door to the environments of space, and then the crazy flames of reentry, man. So you got to be careful in it.
Yeah.
Marty's got a question, but I've got a quick one. Is this one of the few tasks that your crew did inside the VAB? Were there other tasks that you did?
No, we did a lot more. Once we got stacked, we had another week's worth of work to do in the VAB. Yes,
because I was thinking most of you guys would just be in OPF all the time.
we didn't need the number of people in that, but
So
we
you
still
didn't hand off that
no
to anybody in there?
the thermal protection people went with things, just not near as many of them.
Marty, what's your question?
Dean Babcock is asking, was the hydraulic fluid changed on the orbit after every flight or after so many hours of use?
We tested the hydraulic fluid, but I was not responsible for the maintenance of that, so I don't know how often we changed the hydraulic fluid, but it was typical aircraft type hydraulic fluid.
Okay.
I know in the earlier days, our hydraulic pumpers were actually inside the Orbital Processing Facility, extremely noisy in that, and sometimes they would run hydraulic operations for 30 days without shutting those down. So it was ridiculously loud. That eventually they moved them to outside buildings.
Well, glad you're all enjoying Terry White. Always a fascinating program when we have this knowledgeable shuttle worker on board here. And keep the questions coming, Marty. We've got another one.
Yeah, I've got a question from Go On to 1202. Terry, do you have a favorite shuttle?
Actually, the workhorse of the fleet in its day was Challenger. I don't know that I actually have a favorite, but Challenger, we got it together. It went up into space. It did its job. It came back down. We turned it around, sent it back up again. It was just a workhorse. And that, and we talk about the number of flights that the different orbiters had, but the Challenger,
its first 9 flights was really serious business.
Yeah,
and,
yep,
and
yeah.
Of course,
So,
the 10th we lost her.
yeah,
OV 099.
Yep.
Orbital Vehicle 099 tail number. We'll talk about that another day. Well, we've been teasing them. Okay, the Broom Crew. All right, and Carlton Bailey's got a comment. These shots and the ones are the shuttle that flew STS-27. Okay, Atlantis. So an early program there. That's why you don't have the chin. And you do on this one, which is Atlantis, in the
it was 2785 or 89.
I left my scroll over
Okay.
there, but here is the Broom Crew.
All right.
So
and
you called Bob Cabana up one time as director at the Space Center and says, Bob, you want to be part of the Broom Crew?
He got
This
them.
4-time astronaut jumped out of his executive chair, grabbed a car, and was down there in no time, right?
Yep. And they got to be called the Broom Crew because prior to STS-1, when we were trying to get the door closed, it wouldn't close. And it was up there, just hydraulics running and running, and it wouldn't close those last couple of inches. So they took some of the custodial brooms and wrapped them with what we called elephant hide, but it was a protective padding that they wrapped around them, taped them all up, and they used 4 of the big floor brooms to push the door, give it that last little push to close the door. So after that, then we built special brooms, special pads that were for that. And so then the Broom Crew would stand by outside the rope until they got to the point where hydraulics wouldn't bring it up. And then they made the announcement, okay, Broom Crew. And then they did the final push to get it up. So
what a low tech. I can't think of anything other I've heard about this more low tech involved with the high-tech space shuttle than this.
Yeah.
Except maybe you
If it
except maybe you polishing something with your handkerchief.
Oh yeah, if it works, it works. So
it did. But I was kidding, but no kidding. Some people consider it an honor to do this, including
they did. Yeah.
director Bob Cabana,
Yeah,
4-time astronaut.
Yeah, he asked after seeing it, he says, how can I get part of that? I said, we'll call you when it's time.
Check that off your bucket list, Bob Cabana. The things you've done for this great country. And
He was one of the take the boss to work people. So as a center director, I invited him down and we put him to work for several tasks down in the Orbital Processing Facilities. So
very interesting and a perfect shot there, Carlton. Michael Bruno down there in Miami, he wants to know, is a shuttle ever washed between missions?
no, it is not. We had a cleaning substance that was used on the upper wing on the Frizzy, the felt reusable surface insulation, but no, it has an elastomer coating on it, so you could use this special cleaner to clean it off. I don't know what was so special about it, but it was Amway. So,
Okay.
but no, the orbiter was not cleaned. So
Interesting. All right. Well, let's look inside the guts of this a little bit more here as we're winding down this wonderful program with Terry White. We got a lot more things to share with you here, but look how polished that inside panel is. And it's just not a flat panel. There looks like some indents in the top up there.
Up there is to give us the maximum we could put in the way of the size tire on the orbiter. Is there was a recessed area in the main landing gear doors, not in the nose, but the main landing gear doors, so that the wheels could still go up and lock, and then the door could still close, but you had a recessed area in there to give you the maximum size tire.
Something that crossed my mind was the structure there, the physical leg landing gear there. Lots of things in the payload bay and so forth are designed for the weightlessness of space, so that they can't be used on Earth.
Correct.
This appears to be something that had to be
Designed for use on Earth. Yes.
Gravity,
Yes.
as well as space. You couldn't make it. For example, Marty, when we talk about the lunar module, Marty never scurried up the ladder
Yeah.
there because he would have broke it. It'd
Yep.
been like balsa wood,
Yeah.
because it was designed for 1/6 gravity.
But
So
the landing
am
gear,
I right that the landing gear
the
had to
landing
be-
gear serves no function in space,
Mhm.
so it's not part of anything they're using in orbit. So yeah,
But it had to be heavy for Earth weight.
that's right. It
It
had to
couldn't
be
be
able
made
to, had to be
lighter.
able to support the vehicle on touchdown. So
Mhm. Marty, got a question, comment?
Was it, RG Jubilee is asking, was it the insulation or tile on the front wheel that caused Columbia's explosion?
no, Columbia was caused by foam hitting the leading edge of the left wing, hitting the reinforced carbon. Had nothing to do with the landing gear. And that first speculation when they started losing tire pressure in the left main was they thought that the foam had fractured the landing gear door and they were losing the tire pressure because the tires were affected by it, but it was not. It
But
was
that
the
was
leading,
one of the, that was
leading
one
edge
of the
one.
early indications that Columbia was in trouble.
That was a speculation. So when you're speculating something, you need to keep your mouth shut, except in a closed audience.
Uh-huh.
Yeah, everybody says, "Oh yeah, the gear's deploying and all that." No, none of that happened. So
The tire pressure being maintained
yes, sir.
from the all of the physical things going on. That kind explain that. For example, if you get on an airplane, your ears pop because of the pressure. Might clog up
Yeah.
and the shuttle has doors
As
along
vent
the
doors,
vent doors
yes.
to equalize the pressure
Yeah.
in the payload bay, or
Yeah.
things would
But
go.
with the nitrogen, that's not affected much, and there was never an issue with the tires. And we did have the mod that we could monitor the tire pressure. But part of building up a set of tires was you had to put them through a decay process. You build them up, pressurize them, then you had to monitor them for several months to make sure. Because everything leaks. I don't care what it is. If you pressurize it, it's going to leak. It just has to leak a very minimal amount. Yes, sir.
Yeah, Robert Law is asking, but you've already answered this question, but Robert probably came in late. How long did the tires last? Would they be single use or reused?
The mains were single use. Nose was used twice.
Why don't you
generally.
bring up that piece there that you have there? We had appropriate time to do the demo here of a real tire that you brought in.
This is a nose landing gear tire.
Okay. That's the thickness of it. It's at the bottom there. You see 3 areas where all the plies are wound around.
That's the steel.
That's the steel.
All that orange
that
or
is
reddish
steel.
looking stuff. Yeah, that's the steel belts.
That's the steel belt.
Yeah, a lot more than in your car or truck tire.
Yeah, look at that. All right.
And you can see very little tread on the outside of the tire that would touch down. If you look up at there, you can see it's minimal amount.
Marty,
It's
why
nothing.
don't you give the tire a shot over here, buddy? Terry can wheel it over there, and you can zoom in on the tire that's in our exhibit. It is used there. Yeah, there you go. So you see there's not much tread on it.
Yep, and this is another nose tire.
Yeah.
And this is a Goodrich, so this would be from the earlier flights. Like I said,
Mm-hmm.
the first flights were on Goodrich tires.
Steve Jokums, that's an intermediate tire there in our Formula One tire talk there. Yeah, we're happy to have these things in there. I think I can say it finally. That tire we showed there was a tire swing in a space worker's backyard. And I've talked to the children and grandchildren of that space worker who can say Grandpa had that on the tree in the backyard before he donated to the American Space Museum. So anyway, but it is heavy, man. I mean, look at all the plies on that there.
Yep.
Thank you, Marty. That was worth it in there. So, all right, let's get a couple more pictures of some of the...
Cost wise, in the early days, I don't know what a nose tire costs, but a main landing gear tire costs $6,000 a piece.
$6,000 a piece, so a little bit less for that. There you see all the hydraulics, the electronics. I mean, who'd have thunk it that these things are so darn complicated inside there? Just another mechanism of this beautiful spaceship that has to work right every time, every mission, right, Terry?
Yep.
Anything to comment there?
Well,
the trained eye?
one thing to comment about the only time that we had a tire issue was we had high crosswind that day, and so after that, high velocity KSC landings were stopped. So they, that was a contributing factor to that tire blowing, was the wind conditions and that.
There's Carlton Bailey.
And also we did mods for better nose wheel steering, and improvements to the brakes were performed after 51D.
Okay, so aggressive test vehicle, that first 25 missions, of course.
Yep.
To iron everything out. There's Carlton above the row. Why was that so shiny, the door there? What?
That's the type of tape we used. That's
Tape.
tape on the door.
The whole mirror effect up there.
It's tape.
It's tape.
Yes.
Okay.
And it was another weight savings mod.
Did you have to replace that every mission?
No, but we changed out the existing tape that was in there and did a mod where we went with lighter weight and that. And so it took 2 techs 30 days to do the mod, but we shed 4 pounds.
Mm-hmm. Well, what a thrill for you to be in there, CB, back in the day. Like you said, this is STS 27, so yeah, that would probably be like 1988 maybe. 87, well, we had 86, so a bit like 89 probably in there. But he knows, he'll share it with us here in a minute. Again, you got the tires are changed, ready to put back up in there. You see the patina. By the way, the black tiles are what?
Those are the high temperature reusable surface insulation. So those are, the majority of those are LI 900. That means 9 pounds per cubic foot. And some of them
But some of those black ones we see.
Well, the ones that are nice and black looking, they're new.
Okay.
They've been replaced. All the other gray ones have been on for however many flights the orbiter had on at that time. But yeah, so like on Atlantis, 85% of the tiles are original tiles.
I'm so amazed when I look at that beautiful thing hanging up there above my head. I go, wow, those tiles really did work. You don't see a whole.
Yeah, they were designed.
You don't see a whole. You'll see a little area maybe.
Yeah.
And then so you guys learned that you needed to beef up that area.
Mm-hmm. Or something we had to take apart, like when we had to take the antennas off, we had to remove the tiles that were covering the antenna.
There, yeah.
Yeah. So
I forget about all the antennas underneath the tiles in there and other things going on. There's a good look at the hydraulic system and electronics of the main landing gear there. And if you notice, this one, the first one on the left's a little bit scuffed up there.
Yep.
So that's where the smoke
that's what makes
flew.
contact with the runway.
Yep, 200 miles an hour. Wow, right down to the treads there. Marty?
Yeah, Terry, back on SCS-1, you had trouble getting tiles to even adhere to the orbiter. Did you ever think we'd have 85% retention rate on the tires?
I don't know. We didn't do a lot of speculating back then. We were learning a lot of lessons about it. We learned a lot of things from that, and but then some of the things we were doing to make the orbiter better was actually degrading the bonding of the tiles. That happened on Challenger. We had to remove 4,000 tiles 2 weeks before we were supposed to roll out. So yeah.
Appreciate everybody watching today. Robert Law joined us a little bit late from Dundee, Scotland, and he may probably out do a little stargaze of the moon tonight. It's a little fingernail in your backyard this evening. He asked about the use of the tires, and you only use the main tires once. They never were reused.
Yeah.
And twice for the nose tires.
Correct. They were inspected, but only used.
Okay.
But used a second.
So where can I buy one of those tires today?
I
Did they all go out to the Ransom Road junkyard?
No, for a long time they were stored in a warehouse here, and I don't know what they did with them, but there was like 80 sets of tires.
80 sets
stored, yeah, for mains and that. And then I was at the Smithsonian for a presentation before, and they brought out a tire for people to sign when the guests came through, and I said, how stupid can you people be? They took a black tire and painted it white so people could write on it with a black Sharpie. I said, why didn't you just give them a gold Sharpie?
And that's why you were the manager there. So,
Well, this was the Smithsonian, so I had a hard time with that. So,
well, we've got the whole White family watching today. Patricia says hi. Pat's hi to you, Pat. Peggy's probably watching.
Yeah.
Your sister, Pat's your wife, of course. You got your daughter. What's Travis up to? His son has done what 5 deploys to Europe.
Yeah.
Here for the Army.
Yeah.
And
so he is well in Europe now. He's done 2 to Afghanistan, 2 to Iraq, but now he's in Europe. But right now, my other 2 sisters.
Well, how's Travis doing? Hi, Travis.
They're over there visiting him. So he took them off on a cruise, and he's taking them around, showing them Europe as he knows it already. So,
jeez, let's get on that. Let's have a road trip there. But well, we appreciate you today. What an informative show today. Gary Allgaier enjoyed it. Thanks for your input there, Gary. Go on the 1202. There's a real space geek there using some of the Apollo 11 communication abort terminology going on there. Dave Stange, Robert Law, Doug Forrest. Good to see you, Dougie. Dr. Keith Sewell's in Arkansas, a friend of mine, a big stargazer teaching astronomy there. Michael Bruno, Tom Celentano, Nick Deacon. Nick was in Ireland, Marty. Where's Nick Deacon from? He tells that.
No, I don't think so.
Yeah, he mentioned where Nick was from there, but Elena, Ed Hikera, Carlton Bailey, thank you for sharing your pictures today. Appreciate that, buddy. Steve Jokums, go Ferrari. Dean Babcock, Tom Usiak, Gary Gerald, Mitch Rothman, Mark Thiel, good to see Mark. We met him at Shuttle Fest. And RG Jubilee, the one and only Rosalie there. Thank you for watching today. Marty, go ahead with another question.
Well, I have a comment about one of our space fans.
Nick Deakins from the UK,
Okay.
United Kingdom.
Hulk Hogan was a big fan of the space program.
Oh, was he?
Yeah.
He passed away
a
month ago?
Him and his daughter Brooke were invited to the OPF and were touring him around, and I was answering some questions for him and showing him the tile and all that. And I showed him that it was easy to damage a regular tile, but the newer Brie tile that we were putting on the critical areas, the Boeing rigid insulation, was almost indestructible. I showed him how I could tap on it with my pocket knife and wouldn't chip it or anything. So he looks at me and he says, well, if you hit me over the head with a chair or one of those Brie tile, which would hurt me the worst? I said the Brie tile would.
Really? Well, that's a good. I've got a lot of questions about Hulk Hogan, the Hulkster there, but
well, I knew him when he was a bouncer.
Was he a big man?
Yeah, when he was a bouncer at Cocoa Beach.
Oh, really?
Yeah, at the club that I used to go to. Yeah.
Is that right?
Yeah, his first name's Terry.
Oh, is it?
Yeah.
Okay. All right. Died of a heart attack, and
yeah,
kind of sad there that.
Yeah, his career caught up with him when I met him in the OPF. He was, you could tell that he was hurting from all the physical activity they'd done
Is
over
that
the
right?
years. Yeah.
Yeah, there was a lot of physical activity going on in wrestling and football too in there. So Terry's had the privilege of being the tour guide for a lot of VIPs, and we've talked about that. You're welcome to just rack up a show and brag about it someday. But you don't have a picture of Hulkster.
Nope.
And see.
Well, remember in the early days we weren't allowed cameras.
Yeah,
no pictures,
it was
no
film
nothing.
days.
No.
Film days, yeah.
So, but yeah. So when he was in there, unless there was a public affairs person that had the ability to use the camera, but otherwise you just say.
See, I seen a picture of you with Dale Earnhardt.
Okay.
And I think Richard Petty was in that group too.
Yeah.
Prince Charles, maybe? Did you guys a few pictures there with you.
And, politicians and military and that, but they usually kept those.
Well, we thank everyone for watching today's show. We certainly had a lot of viewers. We're gaining a lot of viewers, and that's what our Stay Curious program is all about, is giving you a guest like Terry White here that no one else is interviewing or talking to. Bob Granath yesterday a public affairs officer for several space companies and NASA. Did an excellent program on Bumper 8, the first rocket to be launched off Cape Canaveral 75 years ago. And you all are such great viewers and always have such great questions for our guests. Marty, you've got a final question for Mr. Terry White.
Yes, Tom Usiak is asking, 51D landed in a crosswind. Did the blown tire show any evidence of crosswind stress?
According to the report I read, it did. That's what they credited it to. And the fact of very limited nose wheel steering. I mean, the maximum I think you had then was 7 degrees, which isn't much at all. So.
We got another Formula One fan out there, Dean Babcock. Do you no love for McLaren? Well, our watcher Connie Daniel, she's the one that loves McLaren, the papaya team out there. So Forza Ferrari for me and Steve Jokums there. So great interacting with all of you today. One of our favorite shows is always when Terry comes on because of all the questions that you have. And Terry, as I show a picture of the final time, man, just this is the walk. I'm getting goosebumps thinking about that for you guys. The final orbiter being walked from its landing with a tow truck. You're in that picture, Terry.
Yeah, I think I might be in the light shirt just in front of the left main landing gear.
And
I'm not really sure.
A sad day, we're not going to get into it, but it'd been nice to still have an orbiter around, maybe for national security or some things like that, and launch one once a year. But
or
bring back
stranded astronauts from the space station.
Yeah, bring back stranded astronauts from yes, exactly. And but bittersweet. What a program! You are a national treasure, like we always call our space workers here. But what a legacy. And the shuttle built so extraordinarily, but yet with common parts and pieces,
yes.
like wheels,
yes,
and landing gear adapted off airplanes and
yes.
stuff like that.
Yes.
But what amazes me is your interest out there with our great guests like Terry White here, and your wonderful questions. It's like the Apollo era. There's a segment of our society that will never let it go.
Yeah.
And that's what we here at the American Space Museum never want to let go, the legacy of the Apollo program 50 years ago, landing on the moon. By the way, nobody's done it in 50 years but America. And to everything that you touch and deal with today in your life has some indirect spin-off from the Space Shuttle program of 30 years.
Yep. And you talk about, sad being the last landing. Well, I walked it back to the hangar. You see that picture there? I walked it back to the hangar.
Yeah.
And they were having a special ceremony outside there, and I went home and came back the next day and was unemployed.
Yeah, and as were a whole lot of other good space workers, and many of them found their way in the other companies and doing great things today, and we're glad of that. But this was July 2011, 14 years ago in a month.
Yeah.
When this happened there. Does it seem like that long ago?
Some days it does.
Yeah, particularly after that doctor visit for but no. Anyway, thank you so much, my friend. So you're always a wonderful person. Enjoy getting to know you and your wonderful family, and we'll get Terry on again next month and talk about something. If there's some aspect of the shuttle that you've not heard us talk about, please send me a email or marq@americanspacemuseum.org, and many of you know how to get a hold of us. So thank you all for loving the shuttle, like Dean Babcock says there, and thank you all for loving the American Space Museum. As we all know, that tomorrow is TGIF Friday, and we will be talking about some current events going on. We'll show you some pictures of the Starship launch by our friend Chris LeMarie. Those will be posted on Facebook about 6 o'clock today. And we're going to talk about the auction Saturday, where you can own a shuttle piece of tile that's in a nice little lucite display piece, and so many other things you could own. on the 360 lots that the gavel falls on Saturday at the 39th American Space Museum charity auction. All right. And go to our Facebook or YouTube, or go to Invaluable Auctions if you don't do any of those. Invaluable Auctions is the clearinghouse that Bid Again Auctions uses. So thank you again, everybody. Marty, thanks for a great job there. I think you ran out of ink, maybe, and writing everybody's names down, and his arm got sore from holding up the question sign we have here in the studio. You are all making it happen, and we appreciate it. So until tomorrow, when we'll talk about our 39th charity auction, I'm Mark Marquette on behalf of the American Space Museum saying we'd love to see you in our museum to bridge the space between us.